The last part of the lesson on general angles and radian measure talks about the arc length and area of a sector. Here in the figure you can see what they mean by the arc length of a sector and also the area of a sector, the shaded in region. So you can see the two formulas indicated here. And if you recall from your studies in geometry, when we calculated arc length in geometry, we set up a ratio and said, well, the arc length of the sector divided by the circumference of the circle was equal to the measure of the central angle, and the central angle corresponds to this angle here, the angle here of the sector. So the arc length of the sector divided by the circumference of the circle is equal to the angle of the sector, that central angle, divided by the full circle in degrees 360. And I could cross multiply and solve if I knew the radius and the angle, and I could calculate arc length. If I take that same formula and I convert this fraction on the right hand side, but instead of using a units in degrees, 360, I convert those units, 360 degrees, into radians, 2 pi radians. Now if I cross multiply and solve for s, I get s is equal to, the 2 pi's will cancel, and I'll be left with s is equal to r theta, which is the arc length formula provided here. Now notice to arrive at this formula, I did need to convert this degree measure 360 into radians 2 pi. What that means for us is that in using this formula to calculate arc length, the angle that I use, this angle here, must be measured in radians. If I'm given an angle in degrees, I have to convert it to radians before I can use this formula. The second angle, area, well, back in geometry we also considered this concept of the area of a sector, and again we used a ratio, a proportion. So we said that the area of the sector divided by the area of the whole circle, which is pi r squared, the formula for the area of a circle, would be equal to, and back in geometry we use the measure of the central angle divided by 360. I'm going to replace the 360 with the equivalent measure in radians, 2 pi radians. Cross multiply and solve for A, solve for area. And here when I simplify the expression, I've got 1/2 r squared theta as the area formula for the sector. That's the formula that we're provided with here. Once again, this angle theta, because I substituted, because I replaced the 360 in the proportion with 2 pi, this angle theta must be measured in radians when I use this formula. If I'm given an angle measure in degrees, I'd have to convert it to radians first before I use this formula to calculate the area of a sector. So for example, find the arc length and area of a sector with a radius of 5 centimeters and a central angle of 45 degrees. So once again, before I start using these formulas, I need to convert 45 degrees. Converting 45 degrees to radians, I multiply by pi over 180, which leaves me with pi over 4 radians. Now I can calculate the arc length, radius, times theta. So the radius was given to me as 5. I calculated theta as pi over 4. So 5 times pi over 4, 5 pi over 4 centimeters, because this radius was in centimeters. So the arc length is 5 pi over 4 centimeters. The area, well, that's 1/2 r squared theta. The r is given to me as 5, so r squared will be 25. Theta, I converted from degrees into pi over 4 radians. So theta is pi over 4 radians. And when I multiply, I get 25 pi over 8. And that's area. That'll be centimeters squared. So you could pause this presentation now and try this problem, very similar to the previous example. So finding the arc length, Well, once again, before I start using these formulas, the angle that I was provided, 120 degrees, that has to be converted to radians. So I convert 120 degrees to radians by multiplying by pi over 180. The result is 2 pi over 3 radians. So now for arc length, I can take the radius of 5, the angle theta of 2 pi over 3. S is equal to r theta. 5 times 2 pi over 3 is 10 pi over 3, and that's meters because the radius was in meters. So arc length is 10 pi over 3 meters. For the area, once again, formula is 1/2 r squared theta. R is 5, so r squared will be 25. So it'll be 1/2 times 25 times the theta, which is 2 pi over 3. So 1/2 times 25 times 2 pi over 3. And when I multiply and simplify, I get 25 pi over 3, and that'll be square meters because this is area.